Hey everyone, how's it going? So today's lesson is going to be about balancing chemical equations and also talking a bit about the law of conservation of mass. Let's take a look. Alright, so basically there's this thing that governs how chemistry works. It's called the law of conservation of mass. Basically it says that the mass of what we create in a chemical reaction has to equal the mass of what we started with in the chemical reaction. So basically what that means is we can't create or destroy matter. We're just basically rearranging the pieces into different combinations. So basically this here is our basic chemical equation. We have our reactants, so those are the things that react with one another, and they combine together to make products. So it might be a bunch of things that combine into one product. It might be things that rearrange themselves into different products. But the important thing to remember is that the number of atoms that are in the reactants must equal the number of atoms that are in the products. So that's basically what balancing chemical equations is we want to make sure that the number of atoms on each side match up. So here's a quick example. If we have some iron and sulfur and they react together, we get iron sulfide. So iron is Fe, sulfur is S. When we combine them, they make FeS, which is iron sulfide. And just to keep in mind, we're using the arrow here instead of the equal sign when we talk about chemistry. So, the steps to balancing, we have all of the reactants on the left side of the equation and all of the products on the right side of the equation. You don't have to worry too much about that because you're going to be given the equation and you're just going to have to balance it. So, just for example here, we would have magnesium plus oxygen would combine to make magnesium oxide. And see here, there are two oxygens, and on this side, there is only one oxygen. So right now, it's currently unbalanced. So we're going to be writing what are called coefficients in front of each part of the formula. So if this is our formula here, if there's no number in front, then there's just an invisible one there. So you might be familiar with that when it comes to, well, for example, magnesium oxide. They each have invisible ones there, just because there's no point in writing the one. It's the same thing like if we're talking about math and we're talking about something unknown like x. We don't put one x in front of it, we just put x just to save time. So what we're going to be doing is we're going to be trying to find the coefficients in front of each of these parts of the reaction. So here you can see we have one magnesium and we have two oxygens on the left side. And on the right side, there's an invisible one, and there's also invisible ones there. So we have one magnesium and one oxygen on the right. So we're going to need to balance those oxygens. So right now, this is where we are. We have one magnesium, two oxygens, one magnesium, and one oxygen. And, oops, I don't know what happened there. That's okay. But our oxygens are unbalanced. So we need to put a 2 in front of this magnesium oxide. Because we have two oxygens here, and we only have one here, we put a 2 there so that it multiplies by 2. But when we do that, now we also have two magnesiums on this side. So we can't just add an oxygen on this side. We have to add a whole molecule there to balance it out. Now we have two magnesiums on this side, and we only have one on the left side. So what we do is we have to put a 2 in front of this magnesium here. And now we have 2 magnesiums and 2 oxygens on the left, and 2 magnesiums and 2 oxygens on the right. So this equation is now balanced. So for this example, I'm going to be doing it in another video on my board, and I'm going to be doing one more example from the assignment that should hopefully help you guys finish the assignment. But I hope this video was informative. If you have any questions, always you can let me know. But until next time, have a good one.